Stop that. Good afternoon. Good afternoon. Why would I suggest everyone stand up and give Jensen?
Oh, come on. All right, now I'll tell you whatever you want to hear. So, first of all, I want to apologize for dressing like this. Everybody else is dressed in tuxedos. Nobody sent me the memo. This is what I dress on weekends. And I was taking a nap right before this. I don't get a proper sleep anymore, so I sleep on weekends.
That's awesome. Thank
If
you.
I'm talking in my sleep, you know what happened.
So, I'm supposed to introduce you, and well, I don't think Jensen needs any introduction.
I still want to hear it.
This is an incredible gathering. The auditorium is exceeding its capacity, so keep sharp. Jensen, the visionary founder and the CEO of NVIDIA, I really think he's just making the chips. We're all aligned together. I believe he's changing the course of humanity and civilization trajectory. Because AI is the future we're all stepping into. So for the next 30 minutes, we're going to get him to share with us what is exciting, what keeps you awake, and what challenges you think we're facing. Please share with us some untold story.
Was there a question?
You told me you are going to share your story regardless of the prompt.
What Steve said was he had some questions and he wanted me to read the questions in advance. But I have to prepare. I'm busy. And so I have to prepare for the moment at the moment. You know? And so you gotta ask me a question. Is there a question? First of all, everything I say today that's smart is because I went to Stanford. And anything that I said that wasn't smart, that's because, well, I won't point you up. So where do you want to start?
So really, I think that the first question I would love to ask is, you made a big bet on Buddha. It almost drove your company to bankrupt. But you pushed, you did overcome the resistance and the skepticism of many people at that time. And this turned out to be one of your best success stories. So, is there any moment you can reflect that you want to share with this audience? Also, what will be the next Buddha big bet you think that your company will need to have in the next 30 years?
I want to tell you about some of the big bets that we made, and I'll explain the reasoning that led to the big bet. The first big bet was in 1993. The idea that general purpose computing all by itself, that applications running on CPUs, can't possibly solve many of the interesting problems that we have ahead of us. And the reason for that is because a general purpose instrument is important in almost the development of any category. A general purpose car, a general purpose house, a general purpose anything, whatever it is. But over time, if the category were to expand, it would segment to address niches that are important. In the case of computing, the general purpose architecture allows it to, well, obviously run anything. But the challenges for specialized algorithms, it could be fluid dynamics, it could be particle systems, it could be structured data processing, it could be computer graphics. Whatever these, it could be signal processing, whatever these extreme computation algorithms don't fit nicely in a general purpose computer. And so we imagined that there would be a way to create accelerated systems that could augment the CPU and solve these interesting problems. The problem with specialized systems is that the markets are too small. And if the markets are too small, it's hard to create the flywheel, the R&D flywheel, to add enough value to the central processing unit, which at the time literally had the world's investment in it. And so that's the challenge. How do you find that extreme capability to solve interesting problems on the one hand, but have a market sufficiently large that could create that flywheel? And so we wanted to invent this new way of doing computation. And the question is, how do you get started? And we came up with a great idea. The first great idea of the company was video games. And the reason for that is because video games use 3D graphics, which computationally insanely hard. At the time was Silicon Graphics supercomputers doing image generation. And we said, what if we were to create a system that allows us to do that in a really cost-effective way, but find a very large market on the other hand? And so the problem was 3D graphics algorithms made small required invention, and creating the video game market for 3D required invention. And so the problem for our company at the time, and you'll see this repeated over and over again, that we had to invent two things at one time. We had to invent the technology, and we had to invent the market. Notice artificial intelligence, when it came along, I was quite receptive to the idea. You have to invent the technology on one hand, you have to invent the market. Scientific computing, using acceleration versus very large number of CPUs, we had to invent the technology and invent a programming approach and the whole ecosystem, the market of programming in this way. And so these two-sided problems we were very good at. 1993 made the observation that in many fields of computation, you have to invent the technology and invent the market. That first pillar of our company exists to this day. The second big idea was that if you're a computing platform, install base developers are probably the single most important thing. And that observation, of course, is obvious for anybody who's creating a platform today. But at the time, the idea that we would make all of our accelerators be architecturally compatible. It's the first accelerator system to this day that's architecturally compatible. And we call it UDA. We added eventually the letter to it, CUDA. But UDA started in 1994. So that concept, that architecture, that abstracted architecture, NVIDIA's architecture is abstracted in the sense that it's a hardware platform, it's bare metal, but it's virtualized. It's, to this day, an incredible invention. And we still maintain it in our company, it's really important. And that enabled us to continue to grow the developer ecosystem, create a larger install base. The more your install base, the more developers, the more people buy your products, creating a larger install base. That flywheel started in 1995. Okay? And then the next breakthrough was, of course, CUDA. The problem with CUDA was it was the first investment that we made, or the hardware investment, silicon investment, was it sat inside this graphics chip. Remember, we invented this thing called a GPU. And this GPU was designed for programmable graphics. We invented programmable graphics. When we put CUDA on top of that, the cost of CUDA, the weight of this new feature, was greater than the entire cost of everything that was underneath it. And so you can't double your cost as a company without going out of business. It doesn't exist. And so the challenge for us was, how do we double the cost of our platform when there were no applications? And I still remember dealing with this challenge, and we had to make, it was essentially an existential decision. And the question was, if we build it, will they come? And ultimately what I said was, if we don't build it, they can't come. And you have to believe in what you believe. And to this day, and many employees will, they'll throw it back at you. If there's an investment or a decision or a strategy we want to go pursue, but there's no evidence it can succeed. Zero evidence it can succeed. Somebody will say, well, you have to believe what you believe. And so, but that is at the core of our company. If you look at all of the things that we built, all the systems, and we'll talk about someday, you have to believe what you believe, and you have to pursue that belief. Now, of course, the belief has to come from first principle thinking. You can't just randomly come up with some crazy belief and I'm going to go along with it. The belief has to come from first principle computer science or physics or economics, first principle reasoning with inspiration, added to it inspiration. And that principle thinking, this foundational thinking, is really important in everything that we do. But when you ultimately arrive at a belief system, a vision, if you will, then you gut check that literally every single day. I'm always reevaluating our decisions. If something, continuously reevaluating our strategies and our decisions, if somehow the assumptions that led up to that strategy or that decision were to change, then you have to reconsider, reevaluate. And so that was a big decision, and we believed what we believed and we went with it.
That's fantastic. So this is a Asian American Pioneer Award ceremony. So I want to take this opportunity to ask, as Asian American, and you led your company to achieve a $4 trillion valuation, the most valuable company in the world. And you have amazing breakthrough in the last 10 years. The performance of GPU has increased by 100,000 times. So what is the human side of the story behind this amazing achievement in milestone?
Yes, several things. Moore's Law is 10 times every 5 years, so 100 times every 10 years. And in the last 10 years, we've advanced artificial intelligence by about 100,000 times. The first observation is that our computing platform can enable us to change the algorithm, change the architecture, change the system, change the silicon, and change how we do fundamental computation, basically all at the same time. And we've expanded how we think about computation. About a decade ago, I told the company that the entire data center is going to be one unit of computing now. And a single person will be able to write an application that activates literally every single processor in the data center. That idea never existed before. And we reasoned about, okay, that future were to happen, what would we have to reinvent? What are the things that NVIDIA would have to become good at? How do we think about our own work? And notice we went from a chip company to now we build entire data centers. And a nominal computer for us these days could be $50 billion. And $50 billion is just a massive undertaking. And we're a company today that can start from the ground. I can imagine a blank sheet of paper in front of me and literally architect the entire giant computer from the ground up, and we build every single piece of technology within it. That reframing of our company was important to getting here. At that 100,000, what does that mean? Oftentimes when something happens, in the case of AlexNet, we all saw computer vision become quite effective. Everybody was interested in it. A lot of people were impressed by it. In our case, what we asked ourselves is, what was achieved? Why was it achieved? What does it mean to computing? And where can it go? And so those fundamental questions, when broken down, all the way down to fundamental electronics, allowed us to reinvent everything from the way we compute, the way we do software, the way we develop. Our company has changed. And so you want to reason everything all the way back to first principles. Now, 100,000, what does 100,000 mean? Let's break it down back to first principles. Remember, the reason why Moore's Law was so powerful is it was the greatest technology force deflationary force, depreciating force the world's ever known. That's a big idea. That something that cost a dollar 10 years ago is a penny today. Now, how would that change everything that you do if something important cost a dollar 10 years ago, cost a penny today? Well, obviously, you could do work that's 100 times greater scale at the same price. That's one way of thinking about it. Or you could think about it from another perspective, which is computation is effectively a commodity you don't have to worry about. And so, if you're trying to solve a problem and computation is involved in that somehow, well, its costs won't matter. By the time that you figure out how to apply it, it would have dropped in price and cost by 100 times. Well, now apply it 100,000 times. So what does it mean when computation and intelligence drops in cost by 100,000 times every 10 years? It becomes a commodity that everybody should squander it. You should squander it. This observation led to somebody saying, let's take all of the data in the world and let's put it into an artificial intelligence neural network model and compress to memorize and generalize from all of the data of humanity. That's a big deal. Led to large language models. That observation comes from realizing it's 100,000 times cheaper now.
So this is an amazing story behind all the AI advancement. If you think about 10 years ago, the industry achieved first speech recognition in human parity. Today, both Google and OpenAI achieved analytics golden medal milestone. 10 years, all using GPU, you and your company created. So tell us about what do you think AI is going to evolve? Is AI going to really take all the labor and all the jobs away from all of us? And if that is the case, what is it you're going to say to your grandkids about the sense of purpose for humanity?
Yeah, obviously, really important question, and again, let's reason through it. Okay, first observation. The first observation is in technology, and now more so than ever, there's the first point, which is you can solve the problem kind of. Existence proof. From existence proof to superhuman capability, call it 2 or 3 years. So computer vision, supervision, 2 or 3 years later. Speech recognition, superhuman, 2 or 3 years later. Solving, math problems, 2 or 3 years later, AGI, right? So we know that AGI is now superhuman levels of solving math problems, reading problems, science problems, every single test that you can imagine, solving tests, you're going to achieve superhuman levels in probably less than 2 years. Okay. And so I just said something, solving tests. Now you all know that taking tests is a skill. It doesn't make you fundamentally intelligent. Successful people and people who do well, I met my wife and I made her a bold claim. I was 17 years old and I said, if you study with me every weekend, I promise you will get straight A's the next quarter. Okay, now that was a big, bold claim. Well, it happened. And the reason for that, as you know, is doing well in school is a skill. It doesn't necessarily make you successful. There are many people who are unsuccessful in school and very successful in life. Okay? So my point is that it's just a skill. It's no different than twirling a pencil, there's lots of and these days it's like, and that's just a skill, okay? You're not going to get a job. That won't leave unless there's a job that is about twirling pencils. That's not going to make you successful, but it's a skill. It's not taking tests well and solving problems as you know. It's a skill. And so AI is going to be able to do all of this stuff instantly fast. Now, go back to the first principles and ask, what is AI? AI is about solving these cognitive, reasoning, planning, search problems. You know, if you could frame a problem in that context, we could now solve it incredibly fast at almost no cost with incredible capabilities. Okay, and so for a lot of companies, what that means is that the productivity of your company is going to, of your people are going to go incredibly high. You have to realize that you and I, we have a job, and inside our job, there are tasks. And those tasks can be automated. Those tasks are being automated, our jobs are not. The purpose of our job is different than doing those tasks. It involves those tasks. And so those tasks are going to be done incredibly well now. Companies are going to be very, very productive, society's going to be very productive, and it comes down to one thing. Do you have more ideas that you wish you could pursue if you were more productive? Do you have more, more dreams that you could pursue and make come true if you had more time? And so it comes down to, do you have more dreams? Do you have more aspirations? Do you have more ideas? And if you have those things, then productivity is going to result in your growth. But if you don't, then productivity is going to result in more idle time. And so I think that that's the bottom line. I think it is more likely that we will be busier than ever. It is likely we'll be busier, and look with the thought experiment. Suppose, you're working in a collaborative team, or maybe you're a manager, or maybe you're a professor and you have a bunch of research assistants. Suppose you gave the research assistant a problem, and the answer comes back not in a week, but it came back in a second. So my question is, are you going to be busier or less busy? I send off questions to my company and problems for my company to help solve that are pillars of larger problems and larger systems I'm trying to solve. And I get the benefit of them having to work on it for a week. But if they come back in a minute, then I gotta go, right? I've got to go understand what that impact is and reason about it some more and think and dream some more. And so I think that the answer is because we have so many dreams and problems and challenges and hopes and all that ideas. I think we can just use them.
All right. So today we have a lot of young people. They came here. Go to school. The
one thing that I was going to leave with you, and I applied everything with saying these things consistently to the young generation in front of me. I kept saying reasoning, breaking things back to first principles. That is the most important thing. Now the question is, you can't break things down to first principles if you don't understand first principles. No, you won't understand why magnets are so important if you don't understand Maxwell's equation.
That's right. They attended school. Some of them graduated. They are young. Not all the youth.
Everybody comes to Stanford graduate.
They have a dream. So what is the practical, pragmatic advice you can offer to all those young people? They came here from all over the world. That they can really embrace AI in this amazing, really disruptive era. Because they are concerned about the collective intelligence of humanity will not match the collective intelligence of AGI. This is coming. They see the train is coming.
Yeah.
So what is the practical advice you have for all the young people in our organization?
First observation, as you know, all of our collective intelligence is from the data, the knowledge that was produced by people before us. And so we've been ingesting human data, human knowledge, as a foundation of our own knowledge. And the collection of more knowledge, when you mix them together, and when they're connected, somehow derives other knowledge. We've been absorbing human knowledge, and that's what's on the internet. It was created by all of our ancestors and all of each other. Well, in the future, In the next 10 years, I would think that human-generated knowledge and human-generated data would today be 99%, but in about 10 years, they'll probably be 1%. The vast majority of human knowledge will be generated by AI. It would be AI-generated data that other AIs learn from, and synthetic data generation, we call it synthetic. It's kind of like, for us, it's like calorie-generated intelligence. It's going to be synthetically generated intelligence. That's just intelligence. It's not a big deal. It's just data. I think that, you observe that the amount of AI-generated knowledge is going to be incredibly high. If that is the case, you ask yourself the second question, which is, if you're building a team, and you're working with people, and you want to have friends, do you want the smartest friends? Do you want the most productive friends? Do you want friends and colleagues and teammates that help you the most? If that's the case, then what you have to do is go engage AIs as fast as possible, because they're super, super smart and they're going to help you solve problems. It's also the case that we want second opinions and third opinions, and I use multiple AIs at the same time solving the same problems. And I take the answer from one and I give it to the other and I make the second one. Like the first one, I say, what do you think about this answer? And then I after that mixing, and I ask each one of them to produce, based on everything that you've now learned, why don't you reflect on what I told you and what I gave you, and then give me a better answer. And so notice, I'm interacting with AI the way I'm interacting with people. And I want them on my side. I want them to work with me. And the important thing is, it is impossible to be a researcher in the future without AI. It's impossible to be an engineer without AI. It's impossible to be a manager without AI. It is simply impossible to be a student without AI in the future. And so engage AI.
That's great, Jensen.
Finally,
This is the last question I have. For those in the Asian American community who may have felt that they are unseen or underestimated, and what is your advice?
Well, as you know, I am the American dream. One of these days, if you look it up in Wikipedia, American dream, I'll just probably be a picture of me working at Denny's. And my parents came to the United States when I was 9. They sold everything they had, put it in their pocket. They came, rented an apartment. Neither had a job. My mom was a maid at a Catholic school. My father got a job as an engineer. It was their dream that they would bring us here so that we could get a proper education. And because of everything that my father saw on a business trip one time, and he couldn't imagine that this would be a place where we would build a family. He would build a family, and we would build a life. And they sacrificed and risked everything, literally, to come to a country they'd never been to. And that's an insane idea. Back then, there wasn't internet. It wasn't like my mom's going watching YouTube going, that's pretty good. and so they took it. They got on an airplane, and we came and came to a really alien country, if you will. And they had to learn English here, and my mom had to learn English. Her English is still quite poor, but her English, she had to learn English, and she taught me English. And so the thing that's really amazing is that this is the Chinese spirit for you. You can teach somebody, you can teach your kids how to do something you have no idea how to do yourself. That's a very, very big idea. It's a very big idea that you're going to go on because you care about your family so much that you're willing to pretend. Anyhow, here we are. I think there is. We need to really be careful not to lose the single greatest brand of America, The American dream means immigrants risking everything, coming here, mixing with all of the people that are here before us, rule of law, trust, the ability to take enormous risks, go to incredible academic institutions like Stanford, get a great education, be given a proper chance, somehow risk everything and start a company, and here you are, creating the largest company in history. And you can't underestimate the combination, the delicate combination. It's not a guarantee. This entire system is so delicate. It depends on so many things working together, and I really hate to see us squander that. And I love that generations of Asian Americans were able to come and create amazing. If you look at all of the world's most successful companies, I think 50% of them came from India. Like Sundar and Satya, right? Shantanu. Look at these amazing CEOs running incredible companies, and I love that. I love that this country has created these amazing opportunities for us. And so I'm counting on all of you to carry the banner forward. It is the case that one of the things that we didn't talk about, and I'm rather troubled by it, is the competition between China and the United States, if not delicately framed, gets framed into conflict. And competition is great, conflict is less good. And we need to be careful that our competition with China doesn't change the social attitude about Chinese. And we've got to be careful that we're able to separate countries and governments and people. And in the history that I've been here, in the 50 some odd years that I've been here, we were incredibly good at that. That there was a separation between competition of countries and the needs of countries, and still have this incredible melting pot for all of the people that so many people represented here to be welcomed, to be given proper opportunity, and to be able to do the things that I've had the privilege of doing. And so I hope that we continue to protect that, and I count on all of you to continue to be the shining examples of the American dream and what immigrants can do.
All right, thank you.